Hello ladies and gentlemen, I hope you are finalizing now on your preparations for the final exams. Today let's wind off on transformation. I will give you exam tips on shear and stretch. You should be able to distinguish between shear and stretch. Many candidates fail to distinguish them, but they are quite different. Stretch looks almost like enlargement, but in enlargement, shape is preserved and all lengths are increased and decreased by the same scale factor. But what do we have if a transformation only changes the horizontal length of a figure or only changes the vertical length of figure? What if only one direction is changed? If a figure is enlarged or reduced in only one direction, change is referred to as stretch. I want to show you example of object and image under stretch. This was from November 2010. This was our object and this was our image. Can you see, guys, that it looks almost like enlargement, but the difference is that in enlargement, all lengths are increased and decreased by the same scale factor, but here we are talking about stretch. There is one side that is not going to change. Can you see our PQ? We are having 2 centimeters, and can you see our side P4, Q4, which is the corresponding side on our image? It is not changing. It is still 2 centimeters, but RQ on our image, on our object, it is 4 centimeters. And then on our object, it is 8 centimeters. And this side PR, it is 4.5 centimeters on the object. And then the corresponding side is roughly 8.5 centimeters. This is an example of image under stretch. I'm going to show you another example of image and object under stretch. This was a question in June 2020. Can you see our object? It is PQR, and then can you see our image? It is P2, R2, Q2. This side, which is PR, the length is preserved even in the image. Here we are having it having 3 boxes, and then here P2, R2 has 3 boxes, but P2, Q2 was enlarged, and then R2, Q2 was enlarged also. This is an example of a transformation under a stretch. Now I want to show you a transformation under shear. This was the solution for transformation that was in June 2023. This was our object and this was our image under shear. Can you see the differences, guys? That in our image, all the sides have changed. Our AB here is 4 centimeters. The corresponding side for AB, which is A prime, B prime, we are having 3 centimeters. Can you see that the length have changed? BC is 5 centimeters. Let's see the BC in our image. Can you see the differences, guys? Here it is now 10 centimeters. And then the corresponding side from AC here, it is 4 centimeters. And then for our image, AC is now roughly 9 centimeters. All the sides have changed their length, and then the shape is also deformed. The image was deformed. If you say that the image is deformed, we mean that it has lost the shape. Can you see that it has lost the shape? I'm going to show you another example of shear in the question paper that was in June 2017. Can you see our object? Our object is A, B, C. And then our image is A1, C1, B1. Can you see that this is a shear? the shape has lost the shape, the image has lost the shape, and also all the length have changed. I think now you can distinguish between a shear and a stretch. In summary, when it is stretch, one side length will be the same for image and object, while its other sides are enlarged or reduced. And then for shear, image is going to be deformed and all length sizes are going to be changed. There are two ways stretch and shear is examined in your final. They give you coordinates of object and coordinates of image. They will not tell you if it is a shear or a stretch and ask you to describe the transformation. So first, be able to distinguish between shear and stretch. You get a mark of stating the type of transformation correctly. When describing about stretch and shear, you talk about the invariant line. I will show you how to find the invariant line for shear and stretch. You need also to talk about shear factor if it is shear and stretch factor if it is stretch. So you should know the matrices that are used in stretch and shear. So these are the four matrices that are used in stretch and shear. If it is stretch and the invariant line is y-axis, we use K0, 0, 1. And then when the invariant line is x-axis, this is the matrix that we use. In shear, if the invariant line is y-axis, we use 1, 0, 0, K. And then when invariant line is x-axis, we use 1K, 0, 1, where K is the stretch factor or shear factor. So first I'm going to demonstrate how stretch is examined using the question that was in June 2020 and November 2010. In June 2020, paper 2, part A, we're supposed to draw triangle PQRM with vertices at P, 1, 3, this was our 1, 3, and then our Q, it was 2, 1, and our R, it was 4, 3. After that, I'm going to go direct on the question on stretch. The question on stretch was on part 3 and part 4. On part 3, we're supposed to draw and label triangle P2, Q2, R2. The vertices were 1 minus 6, 2 minus 2, and 4 minus 6. Can you see our triangle P2, Q2, R2? We're supposed to describe the transformation that has occurred. So you was going to get your first mark by first stating that stretch has occurred. And then you get your second mark by talking about the invariant line. Can you see, guys, on our object, this is our P, and on our image, the corresponding point for P is this P2. Their x-coordinate is not changing because here on P, our coordinate is 1, 3, and then on P2, the coordinate is 1 minus 6. Can you see that the x-coordinate is not changing? It implies that the invariant line was the x-axis. Can I show you again on Q? This was 2, 1, and Q2 was 2 minus 2. The x-coordinate is not changing for the image and object. So it implies that x-coordinate, x-axis was the invariant line. And then for our R, can you see here we are having 4, 3, and here it is 4 minus 6. Again, the x value is not changing, so it implies that the invariant line was the x-axis. So you get another mark by stating that the invariant line is x-axis. And then finally, on description of stretch, we need to talk about the stretch factor. There are two ways of calculating stretch factor. I'm going to demonstrate them to you. The formula for calculating stretch factor, we say distance moved by image from invariant line divided by distance moved by object from invariant line. So we said our invariant line is the x-axis. So we need to calculate the distance that was moved by image from invariant line. We are going to take for the corresponding points. For example, if you take our P here, this is our image P2. The distance that was moved by P2 from this invariant line, there are 6 boxes going downwards. So we talk about minus 6. And then the distance moved by P from the invariant line, we are having 3 units. So we are going to say minus 6 divided by 3 in order to get our stretch factor as negative 2. Or we can try other coordinates that are corresponding. Let's say we take for this Q and Q2. The distance moved by Q2 from the invariant line, we are having 2 units. And then the distance moved by object from the invariant line, we are having 1 unit. If we say minus 2 divided by 1, we still obtain our stretch factor is negative 2. So this is the first method that you can use in order to calculate the stretch factor. I want to demonstrate to you another way of calculating stretch factor. You can calculate stretch factor using the matrix method. So here we said the transformation is stretch and the invariant line is the x-axis. So it implies that we are going to use this as our matrix, which is 1, 0, 0k. So in order to find the coordinates of the image, we need to multiply the coordinates of the object by this matrix. So the coordinates of the object, we have 1, 3. So we are going to write 1, 3 in column form. And then we have this 2, 1. We are going to write 2, 1 here. And then finally we have 4, 3. We are going to write 4, 3 here. We want now to write the coordinates of the image. So here we need to write P2, Q2, R2 in column form. Our P2, we are having 1 minus 6. So we write 1 minus 6. And then our Q2, we are having 2 minus 2. We write 2 minus 2. R2, we are having 4 and minus 6. We write 4 minus 6. So we want to find the stretch factor, which is k. We are going to say 0 times 1 plus 3 times k is equals to negative 6. And then we need to make k the subject of formula. It is going to be 3k is equals to negative 6. We divide both sides by 3 so that our stretch factor is going to be negative 2. So either you can use this matrix method, or you can say distance moved by image from invariant line divided by distance moved by object from the invariant line in order to find the stretch factor. So that was all about stretch in June 2020. Let me look again for another question on stretch. This is another way stretch is examined. The question on stretch was on number 12, part E. It is reading a stretch represented by matrix 1, 0, 0 minus 2, maps triangle PQR onto triangle P4, Q4, R4. Draw and label P4, Q4, R4. So we are going to multiply this matrix by the coordinates of object in order to find the coordinates of image. So this was the object, and after calculating the coordinates of object by the matrix which were given, I managed to get the coordinates which I plotted here, P4, Q4, R4, and then after joining them, I managed to have the triangle P4, Q4, R4. So that is simply how stretch is examined. You just need to make sure that you can distinguish that this is stretch and then this is shear, and then you need to talk about the invariant line. You see the coordinates that are not changing for your image and your object, and then finally you need to talk about the stretch factor. Either you calculate it using the matrix method, or you are going to say stretch factor is equals to distance moved by image from invariant line divided by distance moved by object from invariant line. I think that is all about stretch. Let us now move on to shear. I'm going to explain shear using a question that was in CIMSEC June 2023. So first we're supposed to draw and label triangle A, which has vertices at -6, 2, -2, 2, and -5, 6. So this was the triangle ABC, triangle A, which I managed to draw here. So the question on shear was on C part 1 and part 2. We're supposed to draw triangle C, which is the image of triangle A, and has vertices at -6, 14, -5, 16, and -2, 6. So this was our triangle C. And then after that, we're supposed to describe fully the single transformation that maps triangle A onto triangle D. So you're going to get your first mark of stating that shear has occurred. And then when describing shear, you need to talk about the invariant line and the shear factor. The way invariant line is determined in shear is different from the way invariant line is determined in stretch. So what we do when we want to find the invariant line, we need to look for the sides which are corresponding. AC, this side AC is corresponding with this side A1, C1. We need to draw a line that joins A1 and C1, and then we need to draw another line that joins A and C. Can you see, guys, that they are meeting in the y-axis? That is going to determine that y-axis is the invariant line. Can you see for our BC now? If I extend this BC, I will reach here, which is the y-axis. And then for the corresponding side, if I extend this BC, they are going to meet again in the y-axis. So it means that the y-axis is the invariant line. This is how we determine the invariant line when we are talking about shear. So here you are going to obtain your second mark on description by stating that the invariant line is the y-axis. And then finally, we need to talk about the shear factor. The formula for shear factor is distance moved by image point from object point divided by the distance of object from invariant line. We said in this case the invariant line is the y-axis. So let's say we take A and its corresponding points in the image, which is A1. We want to find the distance moved by image from object point. So here we are having our 14, and then here we are having 2. If we say 14 minus 2, we are going to obtain 12 units. It means that the distance moved by image point from object point is 12 units. And then now want to find the distance of objects from the invariant line. This is our object. And then we need to find the distance of object from invariant line, which is the y-axis. Can you see, guys, that we are having -6 units? So we are going to say 12 divided by -6 in order to find the shear factor of -2. So that is why here I stated that shear has occurred. The invariant line is y-axis, or we talk about x is equals to 0. And then the shear factor is -2. That is how I obtained my -2. It is distance moved by image point from object point. So we say 14 minus 2 in order to get 12. And then we say divided by distance of object from invariant line. This is our invariant line, which is y-axis. And the distance of object from invariant line is 6 units, -6 units. So we say 12 divided by -6 in order to get the shear factor is -2. Or you can use the... Can you kindly correct on the shear matrix when the invariant line is y-axis? I didn't realize that I made a mistake. I write the shear matrix, which is the same as the stretch matrix. So the correct shear matrix when the invariant line is y-axis is 10K1. So want to find the shear factor using the matrix method. I'm going to demonstrate to you the coordinates of objects. We are having -6, 2, -2, 2, -5, 6. I need to write the coordinates of the image. We are having -6, 14, -5, 16, and -2, 6. We want to find the shear factor using the matrix method. So we are going to say k times -6, which is -6k, plus 2 times 1, which is 2, is equals to 14. We are going to shift this 14 to the side so that it is going to be -14 plus 2. And then we shift -6k to this side. It is going to be +6k. We divide both sides by 6. If we say -14 plus 2, we get -12. -12 divided by 6 is equals to -2. So our shear factor is equals to -2. So you can either use that method, which I said you say distance moved by image point from object point divided by distance of object from invariant line. So that was all about shear in June 2023. Let us do another question on shear. This was June 2017, paper 2. On number 9A, we're supposed to draw and label triangle ABC, which I've managed to do. And then on part 2, triangle ABC is mapped onto triangle A1B1C1 by a transformation represented by the matrix 1, 0, 2, 1. We're supposed to draw and label triangle A1B1C1. So in order to find the coordinates of the image, we're supposed to multiply the matrix by the coordinates of the object. So we did that, and I obtained my A1 and C1, B1 like this. So on number B, part 1, we're supposed to describe completely the transformation represented by matrix 1, 0, 2, 1. So as I told you that the matrix, when the y-axis is the invariant line, is 1, 0, K1, where K is the stretch factor. That is what is happening here. We are having 1, 0, 2, 1. So it means that this is our shear factor. So in order to describe the transformation that has mapped triangle ABC onto A1, B1, C1, we're supposed to talk about stating that it is shear, and then talking about the shear factor. The shear factor is 2. There are also other methods of finding the shear factor. I'm going to demonstrate. So here, this is our object. Our A is, this is 1, 1. This is our A, 1, 1. And then our A prime, it is 1 in the x-axis, and then it is 3 in the y-axis. So we want to find the distance that was moved by the image point from the object point. This is our image point and this is our object point. We are having 3 minus 1. It means that it has moved 2 units, right? And then the distance moved by object from invariant line. We said our invariant line is y-axis. This is our invariant line. So the distance moved by the object from invariant line, we are having 1 unit. So we are going to say 2 divided by 1 in order to get our shear factor is 2. I want to demonstrate to you how we have managed to say that the invariant line is the y-axis. If we come here and extend this AC, it is going to reach the y-axis like this, right? And then let me draw so that it is going to be feasible. And then if I join the corresponding side, which is A1, C1, I'm going to have this. Can you see, guys, that they are meeting in the y-axis? That implies that our invariant line is the y-axis. So this is how shear is examined. Either they are going to give you the matrix and ask you to draw the image using the matrix, and then after that they will require you to explain the transformation that is occurred. So you can use the matrix method, or you can use that formula of saying distance moved by image point from object point divided by the distance of object from invariant line. This is the summary for shear and stretch. You should know that when it is stretch, one side length will be the same for image and object, while its other sides are going to be enlarged. And then when it is shear, image is going to be deformed and all length sizes are going to be changed. You should know also the matrix that are used when you are dealing with stretch or when you are dealing with shear. You should know these matrices, and then you can calculate the stretch factor using that formula of saying distance moved by image from invariant line divided by distance moved by object from invariant line. And then you can calculate the shear factor by saying distance moved by image point from object point divided by distance of object from invariant line. I think that is all about shear and stretch. Thank you so much, guys, for following me on this channel. Please don't forget to subscribe, like and share my videos. I love you all. This is Eve signing out.